Okay, welcome back to Engineers Workshop. Today I'm going to show you a new tool, new to me tool that I've actually had for over a year, but for some reason have not shared any videos of it. So what I'm going to show you is a new to me Cincinnati #2 tool and cutter grinder, just like Dee Dee has. This is the old school style, motor in the base, flat belt up to drive the spindle. So let me show you the adventures in getting it home, some of the initial assessments that I did and clean up under the table, and do a quick walk around and what is going to happen on the next steps with this machine. So here we go. So here it is in all its glory. This machine was, I believe, set up to do a lot of cylindrical grinding. It came with 2 sets of centers. Did not come with a workhead, but I got a workhead later on from just another source. And unfortunately, I don't have all the bracketry, so I'm going to have to have some fun making my own bracket for the workhead. But basically complete. It did come with a real nice, true 4-digit Mitutoyo digital DRO, 1 scale on the table travel. That's why I was thinking this thing was always doing, cylindrical grinding, because they had real fine control over the in and out. But let's do a little bit of a walk around, and I'll show you the feature. Actually, let me fire it up. I have it, hard switched on, and I'm turning it on and off with the VFD. So let's get that turned on. Now the spindle bearings are great. The motor bearings, I think it could probably use new motor bearings. Motor is in the base. Currently have it on the lower speed. And this brings the table out. And the head elevation is on this side. And then fine table travel is here. This is a gear reduction. If I pull that out, I have coarse travel on these controls here. I do only have 1 crank wheel. I'd like to duplicate this for the other side. Came with a nice work light here, real cheap. And you'll notice I've got the travel there. It's run all the way to the back. So if I bring it forward, that's where I hope to have enough clearance to pivot this table 90 degrees and do a good indication of the wear in the ball races. More on that later. It's exceedingly hard to make this thing move in tenths. Well, not too hard. There's tenths. Okay, I'm near the end of travel of the scale there, so I'm going to stop. Well, I used one basically complete can of brake clean to get what I would call this cavity pretty clean. So I'm just going to start over and start a second can and go over all the surfaces, keep removing more material. The rack looks like it's in very good condition, which I would expect. There is a pathway that's evident in the V-ways for the balls. Now this is kind of interesting. So we've got one that just rides on the point. When the balls wear or the ways wear, I'm assuming that means this table can tilt and not be true front to back. It is what it is. It's going on like this. The manual is explicit that there should be no lubrication on the ways. It does say to lubricate just a light dusting of colloidal graphite. So whatever that is, I hope John Deere graphite will be an acceptable substitute. Using a chip brush to just dab some little bit of graphite on the ways. I don't believe these are factory ball cages. I think the factory one is a continuous strip. There's a light film of oil on these. I need to get that off. I'm going to do another light dusting on the top surfaces. And I'm going to assume that if the graphite is okay to have on the balls, I can put a little bit of that on the rack. And I'd not like to see the rack bone dry. One thing I learned while I was taking this table apart, because you have to push it all the way to one side in order to put the retaining clamps on, you're right at the tipping point, and it started to tip off to the one side. I'm lucky I was quick enough to grab it. So I'm going to put a weight up on this side to shift the center of gravity. That should do it. These are the little clamps that trap there's a very shallow groove. Actually, it's not a groove, but the rack is very slightly wider than the surface it sits on. And then these edges retain that. They let it slide back and forth, but they prevent it from lifting. The ball cages don't let the table run all the way from one end to the other. So you're actually forcing them to slide at this point. Just trying to be very gentle and ease it a little bit more each time. Just enough until that retaining block is exposed. Neat little provision for setting tapers. Kind of a guessing game where these go to drop that table on. The ways of the Cincinnati grinder are set up like this. We've got two V-ways that are bedded in the table casting, and they're on 6-inch centers. Now, instead of having V-ways on top, if you had a V-way here and a V-way here, everything would have to be exactly right, or one of these would never seat correctly. Center to center spacing would have to be perfect. The center line of the V's would have to be perfect all along its length. So what they did was, this one has V-ways top and bottom, which keeps the table from moving side to side. And on this side, this way is flat on top, on the underside of the table. Now, I did some just rough checking with an indicator, and this surface here is actually low. So when I tram the table out, I get a distance of 0.008, 8 thousandths low over the 8-inch table width. What I'd like to do is I would like to turn my auxiliary table crosswise, which gives me a longer indicating surface, and get a better number, because this one had some little bit of warbles in it. I wouldn't call it pitting, but it's a grinder. So I did come back and got back to 0, but I want to get a longer travel on this and see if I can get a better indication of how much is out. Then I'll do the math, and I will add shim underneath this way that has point contact and lift this table up. I'm going to try to hit it dead nuts, but you only can get shim in so many different thicknesses. But cock this table back up. The other thing I'm going to try is, in order to take this apart, that rack sits under here like this. And up on the underside of the rack, there are these little hooked retainers that prevent this table from lifting up. They hook on the back side of the rack. Well, the table has counterbore holes, and there's socket head cap screws from the top that bolt into this rack. So I am going to take those out and see if I can just lift the rolling table top straight off. Just be very gentle with the hoist and leave the rack in place. There does, appear to be maybe one position where it's doweled, and I'm just going to be very careful that I don't damage anything. But I'm going to try to just lift this off to prevent me from having to slide this back and forth and remove those retainers. Wanted to talk about one other thing, though, about this arrangement. On the set of ways where it's riding on the V, there is point contact at these locations. And so the ball is actually spinning about its horizontal axis right here. But the points of contact form a circle that is at these 45s, not at the major diameter. Now the diameter of this circle is not 3/4 inch, the same as the diameter of the ball. And all's well with the world, because as that upper way travels in and out, if the way moves 2 inches, the center line of the ball moves 1 inch, and this way is stationary. But let's look at what happens on that other side. On the flat way, once again, we've got point contact on the balls at the 45 point contact up here. The balls want to roll on these two circles here, which is that diameter. Yet the top of the table wants to roll at that point, which is a much bigger diameter. So, correct me if I'm wrong, something's going to slide. If the balls stay in contact here, they're going to want to roll, let's say, half the distance. But up here, it's trying to travel a greater distance. The ball itself is trying to travel a greater distance. So I figured one of these sets of ways has got to slide, and I'm going to bet it's that one, that point right there. It slides at the single point contact, which coincidentally is the side that's low, so maybe there's more wear in here, and this entire side of the table has dipped. But think about that a little bit if you have one of these grinders, or if you want to just work through that geometry in your head, and leave a comment, see if you think I'm right, if you agree with me, or if I'm all wet. But I don't think you can have rolling contact here, here, and here, and have that travel the same distance as 245 ways rolling on the other set of balls on the other side. Now got over to Henrico Tool & Die and picked up the auxiliary table for the Cincinnati grinder, and they did a beautiful job on this. Confirmed that it did have a 10/1000 hump in the middle, and so they took it down. There was a tiny bit here that did not clean up fully. They didn't want to go any further. As far as I'm concerned, they took the perfect amount off, because this is an area big enough to be bridged by the tailstock centers, and that finish is just phenomenal. I'll get it over to the granite table and check it, but I'm sure this is within a tenth or two. And while I was there, he's clearing out his steel stock, so we threw a small pallet of square and rectangular blocks onto the pallet, ranging from about 1.25 inches thick to 3 to 4 inch square, maybe a couple of 5-inch square pieces, and a nice section of 6 by 6 by 3/4 angle. Probably use that to build a base for the workhead for the grinder. So nice haul. I'll get over to the shop and get these unloaded. Okay, I have my auxiliary table set up in the normal operating position. I have a 6-inch parallel sitting crosswise on it, and I'm zeroed at that end. I'm going to traverse 6 inches, or as close as I can get to it, and see what kind of a movement we get on the indicator. Thousandths, 2 thousandths, 3 thousandths. We're getting almost 1 thousandths per inch of travel. There's 4 thousandths. There's 5/1000ths, a little bit more than that. 4.5, 5 inches. So that's 5.94 inches, and we have 5, 6, 7, 8, almost 8.5. Let's see if we return to 0. 8.5 thousandths in 5.94 inches. And we're right back to 0. So we get closer as we go this way. Now, on the underside of the table, the double V-ways, which are here, versus the double V and the single point contact on top, the double V's have worn more. So they need to shim up. And about, 8 to 9 thousandths underneath that one way to bring this table up to level. So that's interesting. Well, I hope you enjoyed that little look at the Cincinnati #2 tool and cutter grinder and all the good work that this thing is going to do for us down the road. The next adjustment I'm going to make is shimming the way here. I'm going to have to get some shim stock from McMaster and cut it to width, punch the holes in it to match the bolt locations of the actual V-way, and then take that V-way out of the table. And then I can retram it and see where we're at. So that'll be an upcoming project. Meanwhile, of course, we've got the radial arm saw casting to work on back on the K&T. I need to give you a quick follow-up on the Do More tool and cutter grinder. I ended up getting a belt from McMaster on that works better than the factory belt. So I'll show you that and lots of other interesting projects. So thanks again for watching and subscribing. It helps when you hit that like button. If you can do that now, please, with the algorithm, help grow the channel. And I'll continue to bring you videos once a week with all the content that I can come up with for the equipment that I'm acquiring. Might be acquiring another piece here in the upcoming week, so that could be a subject of another video as well. So thanks again for watching and subscribing. Until next time, as always, from Engineers Workshop, stay safe.